Hello, my dear students. Welcome to the subject of statistics for the class 12th English medium, part 2, chapter 5, that is differentiation, presented to you by Vitan sir. This time we are going to learn about a small topic but with a big impact, that is second order differentiation. Basically, it is a very easy concept, but nonetheless it is a very heavy importance of on what you are going to study next. We know that when we find a derivative, that is a differentiation value of a function, we denote it by f dash x. Now we call it first order differentiation, that is the differentiation found for the very first time. So when we try to find the derivative of the derivative of the derivative which we have already obtained, it is called second order differentiation and it is denoted by f double dash x. So I think you are getting my point here, that when we find a differentiated value for the very first time from the given function, it is a first order differentiation. Then whatever answer we have obtained, when we again differentiate it, that is we again find the derivative of the calculated derivative, we call it the second order differentiation and we denote it by f double dash x. Let's see, f dash x is dy upon dx. Now f double dash x is the dy upon dx with d upon dx, that is the second time differentiation. So we will denote it with d into dy, that is d square y divided by dx the whole square. So f dash x is dy upon dx and f double dash x is d square y upon dx square. Okay, so dy upon dx is as good as f dash x and d square y upon dx square is as good as f double dash x. So remember these comparisons, because sometimes they use the function method, sometimes they give us the d symbol, so we have to remember which symbol they are using. This concept is used for finding maximum and minimum values of the given functions. So for example, we can say that maximum revenue function, minimum cost function, maximum profit function, etc. So second order differentiation is found to obtain the maximum and the minimum possible values of any function. We will discuss those concepts afterwards. Let us take some illustrations to understand how do we calculate this. Although this is very easy from the first view, still let us clear it further. First, let us take a function y is 3x raised to 4 minus 2x cube plus x square minus 8x plus 7. So it's quite a lengthy function, but then again it is simple addition and subtraction, no multiplication, and all those things are there. So what we are going to do, we are going to find the first order differentiation, that is dy upon dx here. So 3x raised to 4 is there, so 4 which is in the power right now here, just a minute. The 4 here which is in the power right now will get into the multiplication here, and 4 will minus 1 will become 3. So 3 into 4x cube. Similarly 3 will get into multiplication here and 3 minus 1 will be 2. Now these are some things which we have to do in the immediate steps. We don't have to show additional steps for all of these calculations here. X raised to 2 means 2 will come into multiplication and 2 minus 1 will be just 1. 8x, x will become 1 and 7 will become 0. So in the next step we will automatically solve this. 3 4s are 12, 3 2s are 6, 2 1s are 2 is 2, 8 1s are 8, 0 I have removed. Okay, so now this becomes the first order differentiation. In the next step I am going to find d square y upon dx square, that is the differentiation of this value. So now x cube will become 3x square, x square will become 2x raised to 1, 2x will just become 2 into 1 and 8 will become 0. And when in the next step I open the brackets, 12 3s are 36, x square, 6 2s are 12x plus 2, 0 I will remove. So now this becomes the second order differentiation of the question y. So when we are asked to find the second order differentiation, first we have to find the first order differentiation, that is the simple differentiation, and then using the answer here we have to find the next differentiation. So that becomes the second order differentiation. Let us take one more sum so that we can understand it better. We have to find f double dash 0 if fx is x raised to 4 minus 4x cubed plus 3x square plus x plus 1. So what we are going to do first is find a simple differentiation. First of all, I am rewriting the whole equation here. Then I will be finding f dash x. Now x raised to 4 becomes 4x cube. X cube is there, so 3x square. I hope you guys are getting what I am doing here. X square becomes 2x raised to 1, x becomes 1 and 1 becomes 0, so I am not writing it down here. You must be well versed with how it goes. So in the next step I am simplifying the whole equation. 4x cube plus 4 3s are 12x square plus 3 2s are 6x plus 1. So now this is the first order differentiation. Next I will start with the second order differentiation, that is f double dash x. X cube becomes 3x square, x square becomes 2x raised to 1, x becomes 1, so I have not written it, and 1 becomes 0. When we solve this, 4 3s are 12x square, 12 2s are 24x plus 6. So now this is the second order differentiation. Now what we have to do is we have to find f double dash 0. So in this same equation I will put 0 wherever x is there. So as you can see, I have put 0 in the place of x. So all of those values, this value will become 0, this value will become 0, only plus 6 will remain. So it will be 0 minus 0 plus 6, that will, the answer will be 6. So the answer for this question is 6. So f double dash x, when we take it as 0, f double dash 0 becomes 6. So this is how we calculate the second order differentiation. We will take one last sum in this tutorial. This is a quite small tutorial I have created specifically for understanding the concept of second order differentiation. So we have fx 4x cube plus 2x square plus 7x plus 9, and for which value of x f double dash x is equal to 52. Now this is a kind of question which we have solved with f dash x. Now we have to do it with f double dash x. But for that, first we have to calculate f double dash x, and then we have to assume it as 52. So first of all, I am going to write down the question as it is. Fx is 4x cube plus 2x square plus 7x plus 9. Now this x cube will become 3x square, x square will become 2x, and this x will become 1. So that is how I am going to write it down. 3x square into 4, 2 into 2x raised to 1, 7 into 1 is 7, and 9 becomes 0. And when I simplify this, 4 3s are 12x square, 2 2s are 4x plus 7, 0 will be removed. So now this is the first order differentiation. In the next step, I am going to re-derivate it. X square becomes 2x raised to 1, x becomes 1, and 7 becomes 0. So final answer will be 24x plus 4. Okay. Now, so my second order differentiation for this function is 24x plus 4. What I have to do is f double dash x is equal to 52. So now we take that f double dash x is equal to 52, and in the place of f double dash x I will put 24 plus 4. So 24x plus 4 is 52. I will change the side of 4. So 24x is equal to 52 minus 4, that is 48. Next I will change the side of 24. It will go into the division. So 48 upon 24 is 2. So x is equal to 2. So when x is 2, f double dash x will be 52. So that is the answer to our question. But here we have used the concept of second order differentiation. Now this is the concept we are going to use almost in every next concepts which we are going to study. So we are going to keep on revising it. That's why I am not stretching this particular tutorial further. Last, what I want to say that in a nutshell, finding derivative of a derivative is called second order differentiation. If you remember this thing, if you etch this thing in your mind, finding the second order differentiation will become very easy because it is an easy concept. Next time we will come with the increasing and decreasing function. Till then, stay tuned, stay home, and stay safe.